All right, beta. So today we are going to be doing May June 2020, paper 21, A levels chemistry, AS chemistry, CIE. All right. The first question is gallium is a metal in group 13 of the periodic table. There are two stable isotopes of gallium, 69 gallium and 71 gallium. Okay. State with reference to subatomic particles how the isotopes of 69 gallium and 71 gallium differ from each other. So what's the difference in amongst the subatomic particles? So how are they different? So we have to talk about how they are different. So on what basis are isotopes different? Isotopes are different because they have different number of neutrons, right? So we said they contain different number of neutrons, all right? State what further information is needed to calculate the relative atomic mass of gallium. All right, so if we want to calculate the relative atomic mass, what are the things we need? So for that, you need to know the formula of relative atomic mass. And what is the formula of relative atomic mass? The formula is summation percentage abundance multiply by isotopic mass divided by 100, right? So over here, you do know the isotopic mass. Like for example, the isotope of gallium 69 has a mass of 69 and the isotope of gallium 71 has a mass of 71. But what do you not know? You do not know the percentage abundance, right? So you want to know the percentage abundance of each isotope. This is something you require to calculate the relative atomic mass, right? So the formula of relative atomic mass is given right here. This was not required to answer in the question. You did not need to write the formula down. But if you know the formula, then you do know that according to the formula, we can only calculate the relative atomic mass if we know both the percentage abundance and the isotopic mass, right? Next, gallium and its compounds show similar properties to aluminum and its compounds. Gallium reacts with excess chlorine to form gallium trichloride. At 500 degrees Celsius, gallium trichloride is a gas. Suggest the type of attraction that exists at 500 degrees Celsius. All right. So, between atoms within a gallium trichloride molecule. So any atoms between the molecule, and if they are joined according to what we are seeing, uh, said that they're behaving like aluminum. So we know that aluminum and chlorine, they don't really have an ionic bond. They have a covalent bond, right? AlCl6, they're molecules of aluminum chloride, right? The empirical formula becomes AlCl3, but generally they are dimers, DIMERs. That is what we call aluminum chloride molecules, right? So over here as well, we can conclude that gallium trichloride, because it behaves like aluminum, should have covalent bonding, right? So it should be covalent bonds that should be between atoms, even at 500 degrees Celsius or room temperature, whatever. ठीक है, सही है? And what about between gallium trichloride molecules? So what kind of intermolecular forces should be there? So gallium molecules, just like aluminum chloride molecules, they should be dipoles, right? Because of the difference in polarity of aluminum and chloride, there were dipoles. It was a polar compound, right? It was a polar compound. Therefore, there were induced dipole moments, and that was the intermolecular force of attraction, right? So we are going to say that it is induced dipole, instantaneous dipole, dipole forces. These are the forces that are working. These are also called London dispersion forces. Okay? When gallium trichloride is cooled, a solid Ga2Cl6, there you go, just like aluminum, forms. Suggest the name of the attraction formed between two gallium trichloride molecules to form Ga2Cl6. So if you remember the aluminum molecule once again, uh, Basically, this was one aluminum molecule, one aluminum atom, right? And then around this aluminum metal are three chlorine atoms, right? Kind of like this, right? So this is AlCl3, right? And the chlorine atoms, they share one pair of electron with aluminum because aluminum has three electrons, it shares one electron each. And then the chlorine atoms, they have their own six electrons by themselves, right? This is how the aluminum molecule looks like, AlCl3, right? But we do know that the same exact molecule duplicates, flips, and this is how the molecule looks like, the AlCl6 molecule, if you remember. Okay, so this is how the aluminum chloride molecule looks. The words are now switched up, so let me just correct them, and this will be Cl, 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 and air, right? And the aluminum and the chlorine molecule right here, the two, the three lone pairs, out of the three lone pairs, one of the lone pair is completely donated to this aluminum, right? Like that. And then similarly for this chlorine, out of the three lone pairs, two are by itself and one lone pair is completely donated to this aluminum. This way, everyone has everyone has 8 electrons in its outer shell, but you can see that this bond that is formed, these pairs of electrons are given by one atom alone, right? Aluminum has not donated any in this bonding, right? So these bonds are called the dative bonds. These are called what? These are the dative bonds. Dative bonds are also called coordinate covalent bonds, right? These are the dative bonds. These are both dative bonds. So similarly, they've said that aluminum and gallium behave the same. So we could just literally replace this section with Ga, gallium, and this would be the complete molecular structure of gallium hexachloride, Ga2Cl6, right? Or gallium trichloride, basically, the dimer. So we say dative bonding. Dative bonding, all right? So this is how the gallium Ga2Cl6 molecule looks like. Next question, gallium metal reacts rapidly when exposed to air. A white solid layer is formed on its surface. Suggest an equation to describe the reaction occurring when gallium metal is exposed to air. So they're saying that it reacts when it is exposed to air. So who does it react with when it is exposed to air? So it's obviously going to be reacting with oxygen when it is going to be exposed to air. So to write the equation, we will write gallium reacting with oxygen, and it's going to give gallium oxide. Now gallium oxide, if you write on the side gallium, because it is behaving like aluminum, it should have a +3 charge, and oxide has a -2 charge. So the formula becomes Ga2O3. Okay, and to balance the equation, we have to put a 3 over here and a 2 over here to balance the number of oxygens, 6 on both sides. And now gallium, there are 4 of them, so we put a 4 over here. This is a 2-mark question. So 1 mark would be for the equation and the other mark would be for the balancing, right? If you did want to write the state symbols as well, gallium, because we consider that it is metal, it should be solid, oxygen should be gas, and gallium oxide is an ionic compound over here, just like aluminum oxide, with a very high melting point. So gallium oxide should also have a very high melting point, therefore it should also be solid. Next question. The table gives the formula of each gallium containing product formed when gallium oxide reacts separately with hot aqueous hydrochloric acid and hot aqueous sodium hydroxide. So when gallium reacts with hot aqueous hydrochloric acid, it produces gallium chloride, meaning gallium oxide reacts with acid, and then it also reacts with sodium hydroxide, sodium gallium hydroxide. Okay? Give the name of type of behavior shown by gallium oxide in these reactions. So because gallium oxide is reacting with both acid and an alkali, therefore it will be called an amphoteric oxide. It will be called an amphoteric oxide. This is like knowledge from your past, from your IGCSE or from your O levels. Okay. On to the next question. Question number two. The equation shown in A part 1 describes the reaction which occurs when aqueous potassium iodide is added to aqueous copper to sulfate. A white precipitate of copper iodide forms in a brown solution of iodine and potassium sulfate. Balance the equation and include state symbols. Okay, so we want to balance the equation and we want to include state symbols. For any such question where you have to balance, you should look at a few things. The few things are that you always balance the compounds before the elements. Like for example, this is an element, right? So try balancing it at the end, because balancing it at the end will help. Okay, you do not have to balance potassium iodide to balance iodine, right? First balance everything else and then balance iodine. Okay, so let's start balancing. We can see that copper is once over here, and copper is also once over here. Sulfate is also once over here, but copper is again once over here, and sulfate is also once over here. So we don't really have to put any number before that. Okay. um, However, we have to put a 2 over here, and once we put a 2 over here, then there are two potassiums and how many iodines? Two iodines, and CuI, and so one copper, one sulfate, and two iodines, and one and two, three iodines. Okay, so what we could do is we could put a 1 upon 2 over here, and technically this whole equation is balanced. If you don't feel satisfied with this kind of balancing, then just take it down here and multiply the whole equation by 2. So this becomes 2, and this would become 4, and then this would become 2, and then this would become half multiplied by 2 will become 1, and then this would become 2. And let's see if the equation is still balanced, to see if everything is correct. 2 coppers, 2 copper, okay. 2 sulfate, 2 sulfate, 4 potassium, 2 times 2, 4 potassium, 4 iodines, 2 iodine, and 2 iodine, 4 iodine. Everything is balanced this way as well. So this is also okay, but how we balance it, that would also be okay. Now we want to balance the equation. Let's see what it said. Describe the reaction which occurs when aqueous potassium iodide is added to aqueous copper to sulfate. So these two guys are aqueous, that has been mentioned. A white precipitate means this must be solid, okay, of a silver iodide forms in a brown solution. Solution means this must be aqueous. And potassium sulfate is always soluble, so potassium sulfate will also be aqueous. Why do I say potassium sulfate is always soluble? Because once again, from your past, from your IGCSE or O levels, when you studied salts and their preparations, you studied that all potassium salts are soluble. So anything which contains potassium will dissolve, and therefore will be in aqueous form if there is water. Okay. Next question. The table gives the oxidation numbers of iodine in the different species in the equation. Potassium iodide, the oxidation state of iodine is -1, copper iodide is -1, iodine is 0. Reduce the oxidation number of copper in CuSO4 and CuI. Oxidation number of CuSO4, of course, copper, when it is joined to a sulfate, it is +2 charged, so it will be +2, the oxidation state. And what about the other position? In copper iodide, iodide is -1 charge, so copper over here should be +1 charge, so the oxidation state will be +1 over here. Next question. Describe the types of reaction shown by equation A part 1. Explain your answer in terms of electron transfer. Okay. So how does uh, what does this type of reaction look like? Because the oxidation state of copper changed from +2 to +1, oxidation state decreased, so copper has been reduced. And what if something has been reduced, another thing should be oxidized? Because the question below is a 2-mark question, we have to explain both oxidation and reduction. The type of reaction would be called a redox reaction. That is an easy thing. So what has oxidized then? So iodide over here is -1. It's still -1, but in iodine, iodide is 0. So this is oxidation, increase of oxidation state, right? And then this is reduction. How do I know? Because copper has gone from +2 to +1, right? So the above reaction is redox reaction. The above reaction is a redox reaction. In terms of electron transfer, so we have to use the words that something has gained electrons and something has lost electrons. If it's said in terms of oxidation state, we would say something's oxidation state has increased and other things oxidation state has decreased. But because it has mentioned that we have to talk about electron transfer, we are going to say the species which is reduced has gained gained electrons. So we're going to say the above reaction is a redox reaction as copper ions Cu+2 have gained electrons and are reduced while iodide ions have lost iodide ions I minus have lost electron and are oxidized. Full stop. Next question. In the reaction described in A part 1, a student uses 17.43 grams of CuSO4.YH2O titration. By further titration of the reaction products, the students conclude that the total amount of CuSO4 in the sample is 0.0982 moles. Use the data booklet to complete the table to calculate the value of Y, where Y is an integer. Show your working. Mass of 0.0982 mole of CuSO4. But for that beta, we need the periodic table as well. But I remember that CuSO4 has a mass of 160 exactly, but I might not be correct. But it's okay. Let's see. Um, so what would be the mass of CuSO4? We can check from the periodic table. We don't have a periodic table attached because they said take ideas from the data booklet. So let's check it from a different past paper, but it's all right. Before going to check from a different past paper, uh,
Sir, it's
if any of you
160.
know, it is 160, right? Yeah, I remembered that it is 160 because copper should be 64, sulfur should be 32, and 4 oxygens should be 48. Right? When you add them together, it's 160. So mass equals to mole multiplied by mr 0.0982 multiplied by 160. What do you get?
15.7.
15.7 grams. All right. So we have 15.7 grams of copper sulfate over here. All right. So amount of H2O. How can we find moles of H2O? If we know mole is equals to mass upon mr. But the thing is, we do not know the mass of H2O right now. So mass of H2O, we can calculate mass of H2O equals to the total mass of the molecule with water, not molecule, the compound, 17.43 minus the mass of copper sulfate out of it, right? So 17.43 minus 15.7. Beta, can someone give me the answer to this?
1.73.
Can you repeat, beta? I did not hear you.
1.73.
1.73. Okay, sure. 1.73 grams, right? So we are going to take that as mole equals to 1.73 divided by 18. What would be the moles of H2 over here, beta?
0.096.
So the final answer would be, one second, let me just make all this purple so we can differentiate. The final answer is, can you repeat again, beta?
0.096.
0.096 moles, all right? So 0.096, what is after 0.096?
1.
0.0961. Okay. So 0.0961. We like three significant figures because over here there are also three significant figures. All right. Value of y now. Now, value of y, how would you do it? You would basically just take a whole ratio, right? So you are going to say CuSO4 is to H2O. Moles of CuSO4 were 0.0982, ratio 0.0961. What do? We divide by the smaller number. The smaller number is 0.096. What is the answer, beta? What is the answer to the mole ratio?
1.02.
1.02 is to 1. We can simplify it to 1 is to 1. Therefore, the value of y is 1. Why did I simplify it to 1? Because this value of hydration, you should know this is called water of crystallization, and water of crystallization is always a whole number. Okay. Always remember that water of crystallization is always a whole number. Okay. This is water of crystallization. Okay. On to the next question. Nitric acid HNO3 can be made by reacting nitrogen dioxide with water. The enthalpy change for reaction can be measured indirectly using Hess's cycle. 3NO2 plus H2O gives 2HNO3 plus NO. Explain what is meant by term enthalpy change of formation. Enthalpy change of formation would mean that amount of energy produced, or sorry, produced, the word you never use, right? You never use produced. Yeah, destroyed. It is always released or absorbed. Amount of energy released or absorbed when 1 mole of substance is formed from its elements, right? That is the absolute definition. uh, Amount of energy released or absorbed when 1 mole of a compound is produced from its elements. Okay, so that is the definition. Now they are saying complete the Hess's cycle using values given in the table and hence calculate the enthalpy change delta HR for this reaction. Well, this is going to be a very easy walk in the park because beta, the very simple trick is to write the elements, right? Nitrogen dioxide should be made from the elements nitrogen, which occurs naturally as N2, and oxygen, which occurs naturally as O2, and hydrogen and water, basically meaning H2, right? There is no other element. So these are the guys that we need. Now to balance the equation, because there are 3 N2 over here and there are 3 nitrogens over here, so we can say 3 upon 2 moles of nitrogen. This is only if you did not even write this, it's okay. But because we want to aim for distinction, inshallah ta'ala, so we are going to try and balance everything out as well. Okay. So oxygens on this side are 3 2s are 6 and 1 7. So on the other side, 2 3s are 6 and 1 7 as well. So 7 upon 2 O. And how many hydrogens are there? I guess only 2. By the looks of it, there are only 2 hydrogens on both sides. So H2. Okay. Now we know that we can produce nitrogen dioxide and water, and we can also produce nitric acid and nitrogen monoxide. Okay, both things. And the energy of formations are recorded over here. Now all you need to do is better calculate how many moles of each product is formed. So for example, 1 mole of NO2 when formed produces 34 joules. We have produced 3 moles of NO2, so we are going to write 3 times 34. Beta, what is the answer?
102.
Plus 102 kilojoules, right? So 102 kilojoules, and only 1 mole of H2O is formed. So 1 times the energy released when 1 mole of H2O is formed, meaning minus 286, and that should be minus 286. So when you add these two values together, 102 and minus 286, so you have minus 186 and minus 184 in total, right? This should be minus 184 when you add these two values together. So this arrow depicts minus 184 kilojoules of energy. Okay, now look at the other value. The other value is when 1 mole of HNO3 is produced, when 1 mole of HNO3 is produced, minus 173 kilojoules of energy is released. We have produced 2 moles of HNO3, so we say minus 2 multiplied by minus 173. Beta, what should be the answer?
346.
Please repeat again.
346.
346 with a negative though, right? Because it is a negative sign. So when you multiply minus 173 with 2, you should get minus 346. And 1 mole of NO is formed. So 1 multiplied by 91.1. What would be the answer, beta? अरे 1 से ही multiply करना तो मैं ही कर लेता लो. So it should be 91.1. Okay. And what would be the total answer?
Minus 254.9.
Minus 254.9. Okay, this is everything we've done, right? Now the thing is, we actually wanted to calculate this way, but we can't find delta H directly because there is no clear path. So what do? We make our own path. So we go down here and then we come up here. All right, and because this arrow is opposite in direction to this arrow, so the value of our arrow should be plus 184. And because this arrow and this arrow are both in same direction, so value of our purple arrow should also be minus 254.9. So you will finally write delta HR is equals to plus 184 minus 254.9. What would be the answer, beta?
Negative 70.9.
Negative 70.9. That would be our final answer. So this is a very easy question for free 3 marks. All you need to do is be good with your vector skill, right? In IGCSE or O-level maths, you have studied vectors. You should just know that vectors which face opposite directions have opposite signs. That is all. And then you should just know that general unitary method and arithmetics, that when 1 mole is produced, this much energy is produced, so 3 moles would be 3 times that energy. Anyways, nitrogen and oxygen do not react at normal atmospheric temperatures. Explain why. Why does nitrogen and oxygen do not react at atmospheric temperatures? Not because of oxygen. Oxygen is always ready to react. However, nitrogen isn't. Nitrogen really has some problems. And what is that essential problem? It is that nitrogen-nitrogen triple bond that it has, right? A nitrogen-nitrogen triple bond is very strong, and it is good if you remember the value. This bond enthalpy of this bond enthalpy, like enthalpy of this triple bond, is approximately 1,000 kilojoules per mole. Do you understand what that means? It means that 1,000 kilojoules of energy is required to break this bond, and any reaction only begins after its old bonds are broken. So every reaction requires old bonds to be broken. So because this old bond needs so much energy to break at room temperature, that much energy is not available. Therefore, the reaction does not take place. So we have to answer it this way. So we are going to say that N2 molecule contains a nitrogen-nitrogen triple bond which requires very high energy, and in bracket you can even mention, if you remember, approximately 1,000 kilojoules per mole to be broken so that it can participate in any other reaction. This is the only one reason why we say that nitrogen is technically inert at room temperature, it does not react at room temperature. Okay, nitrogen oxides can be formed naturally in Earth's atmosphere from nitrogen and oxygen in the air state. One way that nitrogen oxides are produced naturally due to lightning strike. It is a very famous phenomena, lightning, right? Due to lightning, it is a very famous phenomena that whenever there is a thunderstorm or lightning, nitrogen in the air gets oxidized. All the nitrogen around that lightning bolt gets oxidized because you should remember, beta, that lightning strike is also energy in the form of electrical energy. And in many scripts, we talk about these bond energies in electron volts. Why do we say electron volts? Because electron volt, matlab charge multiply by voltage or potential difference, is also a form of energy, right? It is also a form of energy. So we can say that either we can talk about energy in the form of joules, or we can talk about energy in the form of electron volts, meaning anything that has electrical potential has energy. Therefore, if nitrogen is around it and there's high electrical potential, like the lightning bolt, so it will ionize that nitrogen. And when the nitrogen is ionized, it is going to produce its radicals, and those radicals will then react with oxygen. Anyways, on to the next question. Nitrogen dioxide NO2 acts as a homogeneous catalyst in oxidation of atmospheric sulfur dioxide. Explain why NO2 is described as a homogeneous catalyst. So what is a homogeneous catalyst? So first of all, you have to explain what a catalyst is. You have to explain what a homogeneous catalyst is, right? So homogeneous would mean that NO2 and SO2 both have the same physical state, which is gas, right? NO2 is called a homogeneous catalyst. NO2 is called a homogeneous catalyst as it is in the same phase as SO2, and in bracket you can say IE, both are gases. Both are gases. Okay, so once this has been mentioned, what do you do next? The next thing you're going to do is, because this is a 3 mark question and I can clearly see that I believe 2 marks would be for homogeneous. No, sorry, 1 mark should be for homogeneous and 2 marks should be of catalyst, because the catalyst definition is also very crucial. So we are now going to define NO2 provides an alternate path for SO2 to oxidize, which requires lesser activation energy without being used up itself. This is a complete answer. Okay. Next question. Write equations which describe the two reactions occurring when NO2 acts as a catalyst in the formation of sulfur trioxide from sulfur dioxide. Okay. So two reactions that are happening in the formation of sulfur trioxide from sulfur dioxide. Okay, so how are sulfur trioxide and sulfur dioxide forming, or how is that happening? Basically, why are there two reactions? Because NO2 acts as a catalyst in a different way. NO2 does not necessarily not take part in the chemical reaction. As we grow, we are going to realize that it is not necessary to understand it this way, that catalysts do not take part in the chemical reaction. No, actually catalysts do take part in the chemical reaction, but the chemical reaction proceeds in such a way that at the end of the reaction, the catalyst, it returns back into its original formula, right? So for example, over here we are going to write two equations. The equation for sulfur dioxide converting to sulfur trioxide goes like this: NO2 first reacts with SO2 and helps produce sulfur trioxide by converting into nitrogen monoxide. But then this nitrogen monoxide quickly reacts with more atmospheric oxygen, okay, to produce nitrogen dioxide again. These are very famous two equations. They are written in your environmental chemistry portion. I think you will find it in the nitrogen chapter, which is chapter 2.4 in the notes. Okay? So yeah, this is where these two equations were mentioned. So as you can see, the nitrogen dioxide remained as nitrogen dioxide by the end of reaction. Therefore, it is called the catalyst. It does not mean that it did not at all react with sulfur dioxide. It did. This is who started the reaction anyways. Okay, on to the next question. Calcium nitrate CaNO3 whole twice reacts with ammonia, carbon dioxide and water to form a mixture of ammonium nitrate and calcium carbonate. Calcium nitrate reacting with ammonia plus carbon dioxide plus hydrogen gives ammonium nitrate and calcium carbonate. Okay, sure. Explain why ammonia is described as a Bronsted-Lowry base in this reaction. So for that, you need to know the definition of Bronsted-Lowry base. So Bronsted-Lowry base is any base which accepts a proton. As you can see, NH3 becomes NH4. It has received an H positive ion. Therefore, NH3 ammonia is called a Bronsted-Lowry base. We will say it accepts, yeah, gains a proton. We have to use the word proton, not just the H positive ion, right? We have to mention proton because Bronsted Lowry explained their theory on the basis of proton. They did not use the word H positive ion. Okay? The product mixture, however, for proton is an H positive ion and H positive ion is a proton. The two are synonymous to each other. The product mixture can then be added to soil. State two reasons why this mixture of products is added to some soils. Two reasons are very good. First of all, it contains nitrates, which will give nitrogen content to the soil, helping plants grow. So it has a fertilizer. And then what does calcium carbonate do? Beta, calcium carbonate is called limestone and it is chalky in nature. And in agriculture, in the one use of calcium carbonate that you have studied, you should study, is that it helps neutralize the soil. It helps neutralize the soil if the soil is acidic in pH. Okay? So we will say CaCO3 helps neutralize the soil. And the nitrate guy, NH4NO3, acts as a fertilizer and provides nutrition to plants. Full stop. Next question. Complete the table to name the shape and give bond angle of each species. CO2, as you remember, you should remember, it is a linear compound, right? Because it contains one central element joined to two atoms, right? So linear bond angle is 180 degrees. Okay. NH3, if you remember, NH3 is having a what kind of shape? A pyramidal shape, not a trigonal shape. Why? Why does it not have a trigonal shape? Because it contains a lone pair. So the trigonal shape is disrupted. So this is called a pyramidal shape. Pyramidal shape, and the bond angles of pyramidal shape are 107 degrees. Okay? And H2O, if you remember, oxygen bonded to two hydrogens, it looks like this. Oxygen, why does it look like this? Because oxygen contains two lone pairs, right? Okay? This is called bent. This is called bent, also called non-linear, yeah, bent. Okay? When there are two atoms joined to a central element and the central element also contains two lone pairs, the shape is non-linear or bent and the angle is the least possible one, 104.5 degrees. Okay? Next question, beta. Below is a list of species which can react with organic compounds, cyanidine, HCl, chlorine, water, carbonate. From list, identify species which can react with ethane. So who reacts with alkanes? chlorine does. Okay, so chlorine is very famous for reacting with alkanes, so we say Cl. From the list, identify two species which can attack pi bond in ethene, meaning which two species out of them have the potential to attack pi bond. सही है? So pi bond, meaning the double bond, if you remember, was attacked by electrophiles, and electrophiles are having a partial positive nature themselves. If you remember, remember alkenes used to react with hydrogen chloride because H has a partial positive nature, and HOH of water also has a partial positive nature. Steam distillation कह रहा हूँ. Addition of steam on alkenes and addition of hydrogen halide on alkenes, both are very famous electrophilic addition reactions. ठीक है, तो we are going to say HCl and H2O, electrophilic addition reactions. You guys can refer to that part of the chapter hydrocarbon. Electrophilic addition reaction beta. Okay, on to the next question from the list. Identify species which can be used to distinguish between solutions of propanoic acid and propane phenol. Describe any relevant observation. How could you distinguish between propanoic acid and propanol? So you just have to see which compound reacts with either the propanoic acid or the propane phenol, and the answer is very simple. If you remember, carbonate ions, they react with acids and produce carbon dioxide, right? So we are going to say carbonate ions, CO3 minus 2, carbonate species. What will we say? It reacts with propanoic acid and produces CO2 gas, while it does not react with alcohol, or not alcohol, let's specify propane phenol. Propane phenol, full stop. All right, on to the next question. Cl gas can be made from Cl2. Describe the conditions required for this process. Very simple. What do we require? UV light. Is that not true? We require UV light. Name this process. How can we produce chlorine radicals from chlorine? What kind of reaction is this called? Yeah, what kind of process is this called? Homolytic fission, right? The breaking of chlorine into two Cl radicals, that is homolytic fission. If you guys thought the answer should be initiation, no, that is only a step of part of a chemical reaction called free radical substitution reaction, right? That is not a process, it's only a step of a chemical reaction. The process is homolytic fission, which occurs in presence of UV light in chlorine to produce chlorine free radicals, right? Name an organic functional group which reacts with a nucleophile in an addition reaction. Okay, so an organic functional group which reacts with a nucleophile. So first of all, if you look at these guys, this is a nucleophile. And where have we studied the reaction of cyanide ion? So if you remember, the nucleophilic addition of carbonyl compounds to produce hydroxynitriles. That was the whole thing. Carbonyl compounds, organic chemistry under, you studied in ketones and in aldehydes that carbonyl compounds, they react with cyanide, meaning hydrogen cyanide in presence of potassium cyanide KCN. Yeah, directly KCN in presence of an acid because you require acidification. So you would prepare hydroxynitriles, right? In ketones, it is a branched nitrile, and in aldehydes, it is an unbranched nitrile. The students who were in my physical class this Sunday, I believe, studied that this way. Okay? So we know that carbonyl compounds, and which carbonyl compounds? The true carbonyl compounds. And which are the true carbonyl compounds? Aldehyde and ketone. ठीक है. Next question. Name an organic functional group which tends to react with a nucleophile in an SN1 substitution mechanism. So SN1 substitution mechanism is a substitution mechanism in which reaction is limited by one reactant. It's a fast reaction. ठीक है. In SN1 reaction, who takes place in SN1 reaction, or where have we studied SN reactions? We have studied them in halogenoalkanes, right? SN1 and SN2 mechanism. SN2 mechanism was followed by primary halogenoalkanes, and SN1 mechanism was followed by tertiary halogenoalkanes. If you remember that, this is something you have to remember, that SN1 mechanism is followed by tertiary halogenoalkanes, full stop. Okay. On to the next question, beta. But1-ene reacts with steam in presence of concentrated phosphoric acid to form two isomers of molecular formula C4H10O. Okay, each reaction occurs via different intermediate ion. Draw the structure of both intermediate ions. It is a very easy question once again. देखो बेटा, it is but1-ene, carbon, double bond carbon, single bond carbon, single bond carbon. Okay, these single bond carbons, they actually don't really mean anything to us, so we can just write them as CH3, and we can write this as CH2. Only these guys are important to us: carbon, hydrogen, hydrogen, and hydrogen. In the reaction of steam, the nucleophile attacks this carbon-carbon double bond, and one of these bonds breaks. I will highlight that with a purple line. Okay, so yeah, and let's suppose this is the nucleophile HOH. Why should we suppose? They have given us that it is an H2O reaction. Okay, so the nucleophile has sorry, the electrophile H positive has a partial positive charge, and it will attack the carbon carbon double bond. Why? Because the carbon carbon double bond, or the pi bond, or the unsaturated carbon, have high electron density in the double bond region. There are a lot of electrons over here, 4 to count. Okay, so because of high electron density region, this region becomes a center of attraction for all electrophiles, things that are looking for a negative charge, because there are a lot of electrons over here. So we always draw the curly arrow from high electron density to low electron density, meaning electron rich to electron deficient species, right? But the attack is obviously this way. That is why it's called an electrophile attacking it. Okay, but anyways, when this happens, the hydrogen joins, right? The hydrogen joins, and the compound looks like this. Let me just quickly duplicate it. Right, it looks like this or this, because they've asked us to draw two, right? Now the hydrogen that has just attacked will now join either with this carbon, or it will join with this carbon, because it has the tendency to join with either of these carbons, right? But then which carbon will it join with more? It will depend upon the carbocation that is formed. So in this case, this will be the carbocation because now it has one less bond. And in this case, this will be the carbocation because it has one less bond. And because you can see clearly that this is a secondary carbocation, this is a secondary carbocation, and this is a primary carbocation, right? Secondary carbocation, primary carbocation, and because this is a secondary carbocation and this is a primary carbocation, they are going to ask, they are asking circle the more stable intermediate and explain your answer. So which is more stable? Of course, secondary carbocation is more stable. You're going to circle that. Okay. Why do we say secondary carbocation is more stable intermediate? Because according to Markovnikov rule, secondary carbocation is more stable because of increased positive inductive effect, right? According to Markovnikov rule, secondary carbocation is more stable than primary carbocation, right? Secondary carbocation is more stable than primary carbocation because of increased positive inductive effect. This is a very important question for all the students appearing in 2025 May June, because as you can see, this question was repeated in 2020, it was repeated in 2021, but then it did not come in 2023, 2024. It did come in 2023, I believe, but not in 2022 and 2024. So now there is a high chance that it will appear again. Okay, it might not appear as H2O. The same reaction mechanism works. If it was instead of steam it was HCl, the same reaction mechanism would take place, beta. Okay, so that does not matter, but electrophilic addition reaction always follows this kind of pattern. Okay, so you should always remember that. And on to the next question. I believe this is the final question of this paper. 2-methyl butadiene reacts with acidified manganate ions, meaning something like potassium magnate, under specific conditions to produce two organic compounds X and Y. So it is alkene. Okay. X immediately reacts with acidified potassium magnate ions to form carbon dioxide and water. Y has a structural formula CH3, CH2CO, CH3. Okay, so 2-methyl butadiene, potassium magnate, X and Y, CO2 and H2O. X immediately reacts with potassium magnate, acidified magnate ions to form carbon dioxide and water. Okay, sure, whatever. And then Y, draw the skeletal formula of 2-methyl butadiene. I was going to draw it over here anyways to understand what was happening over here, but they've asked us to draw the skeletal formula of 2-methyl butadiene by anyways. So let's draw pehle structural formula. So butene with carbon-carbon double bond on the first one and CH3 over here, right? So the skeletal formula should look like this. Now, when you draw the skeletal formula, the carbon-carbon double bond is in the center, right? And then we have like basically um we have basically that thing. What do we say? The skeleton. In that we do not show hydrogens, right? So the carbon-carbon double bond is on the first carbon and the second carbon, and then this guy. So now we have three carbons shown, and then here's the fourth carbon. Okay, and then here's the fifth carbon. Okay, so this is the skeletal formula. Just make it a little more straight. Okay, so this should be 2-methyl butadiene. You can see there are one, two, three, four carbons in the first, in the main chain, and then a methyl group. Okay. However, to understand it better, some of you guys like to write it like this: carbon double bond carbon, CH3, C2H5, H and H. So already you guys can see that this side produce carbon dioxide and water, as we have discussed that the oxidation of alkenes in hot concentrated aqueous potassium magnate conditions produces either carbon dioxide and water if the unsaturated carbon has both hydrogens attached to it, and it would produce a ketone if the unsaturated carbon has two carbon chains attached to it. And that is why we see a ketone formed over here, and we see carbon dioxide and water finally formed over here. Let's see what they're going to talk about X. State the specific condition required for a acidified potassium magnate ions to react with 2-methyl butadiene. So what is the specific condition that would be required over here? Okay, so yeah. So I've just mentioned that the acidified potassium magnate would only react in this way to produce these products if it is hot and concentrated. Okay, so we are going to say that it must be hot and concentrated. It must be hot and concentrated, right? Next question. Name the type of reaction occurring to functional group in 2-methyl-butanene in reaction B part 1. Name the type of reaction occurring to functional group in 2-methyl-butene. So the alkene, what is the type of reaction that is happening over here? Because of acidified potassium magnate, the reaction is always oxidation reaction. This is an example of an oxidation reaction, right? So this is an oxidation reaction. Next question, draw the structural formula of X. We have to draw the structural formula of X. Okay, so X is formed before carbon dioxide and water. And before carbon dioxide and water, if we just combine these things, this actually is formed from a carboxylic acid intermediate, right? So the structural formula of X would look like this because it contains a single carbon. This is always methanoic acid, right? So X is actually methanoic acid that is formed as an intermediate. So we say HCOOH. This is methanoic acid. On to the next question. Describe a chemical test and expected observations to confirm presence of carbonyl functional group in Y. How can we confirm carbonyl functional group? We say that we add, there is only one test that we require to confirm the presence of carbonyl functional group, meaning to confirm presence of aldehyde or ketone, and that is to add 2,4 DNPH. Add 2,4 DNPH. What is 2,4 DNPH? Dinitrophenyl hydrazine. DNPH stands for dinitrophenyl hydrazine to unknown sample. Full stop. If sample contains carbonyl group, then solution, not solution, let's say orange PPT forms. Then red orange PPT forms. Red orange PPT forms, precipitate forms. Full stop. On to the next question. The infrared spectrum of 2-methyl-butanene is shown. Okay, so infrared spectrum of this guy is shown, 2-methyl-1-butene. Okay, predict two main differences that would be seen between spectra of Y, which is a carbonyl carbon, and 2-methyl-butanene. Give reasons for your predictions. Your answer should refer to only regions of spectrum above 1500. As you guys would know from my lectures, beta dekho, the initial regions, this region is almost useless. Everything over here is useless on the infrared spectrum, meaning about up till 1400 on the spectrum, on the wave number value 1400, anything is not identified. It is not easy to identify all that. It is what we call the fingerprint region, the region which is common in almost all organic compounds. So we don't really worry about that. What do we worry about? We worry about things that are up ahead. Like for example, this peak is because of the carbon-carbon double bond that is present in 2-methyl-butanene, right? Carbon-carbon double bond that is present over here. Okay. Now in the Y, because there is a carbonyl group CH3, CH2, C double bond O, CH3, right? So this is a carbonyl group. And beta, I have told you to not go to the data booklet because at your level, infrared spectroscopy is so easy. You just have to remember that carbonyl carbons produce a very sharp sword. Carbonyl carbons produce a very sharp sword-like peak at something like 1750 to 1650 range, right? 1650 to 1750 range. That is where a very sharp sword-like range is produced. In the data booklet, that range is referred to as the carbonyl peak, right? The carbonyl peak will be observed in compound Y, whereas the carbonyl peak is not observed in 2-methyl-butanene. And then the other one is the carbon-carbon double bond, yeah, the presence of saturated carbon is shown by this peak at roughly 2900. Okay, it would not be seen in compound Y. So we are going to say that compound Y, या फिर ऐसे लिखते हैं, the peak present at, या पे present between कर लेते हैं because we don't know, 2900 to 2800, present between 2800 to 2900 centimeter inverse is the will be absent in IR spectrum of compound Y. Full stop. Moreover, compound Y contains a carbonyl functional group. Hence, you guys can write the absolute correct value from the data booklet, but I remember it to be 1650 to 1750. Hence, a peak, a sharp peak would be observed between 1650 to 1750 centimeter inverse. A sharp peak would be observed between 1650 to 1750 centimeter inverse in the IR spectroscopy of compound Y. These are such obvious things, beta, but you guys have to use a little bit of knowledge and a little bit of common sense to find these answers. All right. Next question. Propanoic acid CH3CH2 COOH is reduced by LiAlH4. Write an equation to show this reaction. Use H to represent an atom of hydrogen from the reducing agent. Okay, sure. So propanoic acid can be reduced, and what can it be reduced to? It can be reduced to aldehyde or alcohol, right? Because they have not mentioned to reduce it to aldehyde or to alcohol. The general idea is we reduce propanoic acid, it goes all the way down to alcohol. Okay, so we are going to write CH3CO, no, not CH3, C2H5COOH. ठीक है, this is propanoic acid. When it reacts with hydrogen, it reduces hydrogen all the way down to alcohol, and the alcohol is C2H5CH3OH. Basically, the end part has been reduced all the way down to this thing. If you guys count out the number of, या फिर इसको इसी तरह लिख लूँ यार, let's write it as C3H7OH. ठीक है, if you guys count 5 and 6 hydrogens, and over here 7 and 1, 8 hydrogens, and then one oxygen is also reduced. That oxygen makes water. So a total of 4 hydrogens are required to reduce it completely. Total of 4 hydrogens are required to reduce it completely. ठीक है. Next question. Name the organic product formed by this reaction. Beta, this is propane 1-all. Propane 1-all. It's a primary alcohol because alcohols, carboxylic acid reduces to primary alcohol. Next question. Organic compound W is an ester which is structural isomer of propanoic acid. State the molecular formula of W. Propanoic acid and structure W. Propanoic acid's molecular formula is the same molecular formula that would be the molecular formula of W. Why? Because they're isomers, so they should have the same molecular formula. So propanoic acid we've written as C2H5COOH, right? This is propanoic acid. So the molecular formula would be C3 H6O2. That is the molecular formula. And now ester, because it contains the carbon, double bond oxygen and oxygen, it should contain 6 hydrogens now. So CH3 and CH3, this is a possible structure of the ester of propanoic acid, the isomer ester of propanoic acid. But we do know from our knowledge that esters and propanoic acids are structural isomers, specifically functional group isomers, because they contain the same different functional groups with same molecular formula, right? Another possible answer, the only other possible answer, in fact, could also be this: H C double bond O O C2H5. ठीक है? I will write names of both these compounds as well. This compound is called methyl ethanoate, and this compound is called ethyl methanoate. Okay, we could not have any other possible structures. How did I name it? Just break these bonds right from over here. So this side is the alkanoate side and this side is the alkyl side. The alkyl side contains 1 carbon, so it's methyl. Alkanoate side contain 2 carbons, ethanoate. Okay, and on this side, the alkyl side, the alkanoate side contains 1 carbon, methanoate, and the alkyl side contains 2 carbons, ethyl. Okay, this is how the names are written. Well, they did not ask you to write the names, but they asked you to write any one of these molecular formulas and it would have worked. So this is how you write this molecular formula. And with that, this 2020 paper is also completed. If you guys have any questions, you can turn on your mic and ask ahead.